Okay, it's Tuesday again. It's 1 o'clock, and that means only one thing, that we have another episode of our HDF Clinic. Welcome, everybody. Thanks for coming. I checked our Google document. I didn't see any questions there, but I'm going to pause and ask for those of you who were able to join, are there any questions?
No questions for starters, Gerd. Thank you.
Okay, thank you. Okay, then let's just go through our usual motions, announcements. We will have on April 1st, not a joke, we will have a great seminar presented by John Reedy, co-presented by John Reedy, about using HDF5 and HSDS, that's the highly scalable data service, for open science research at scale. And I believe there is a Zoom link that comes with that. I believe registration is not even necessary. I apologize, I didn't check that. And okay, but yeah, if you follow this link, if there is a registration, you will find it. And if there isn't, there's just a Zoom link and you can just join. And then a reminder, we will have the HDF user group meeting hug in Europe in end of May, early June at ITA in France. And it's going to be a hybrid in-person and online meeting. And yeah, as I said last time, reserve your spot before telling your friends, because registrations are rolling in, and there is only, I think the main limitation is not so much hosting people there on site at ITA. It's really, there is a cap on, there will be, as one of the treats that comes with being there in person, is to take a tour of the ITA facility, which is still under construction, but pretty far along. And there is a limit on how many people can be on that tour. And so that's why you want to register early and sort of save your spot. Okay, forum. Lots going on in the forum, and it's really just sort of a snapshot and what caught my interest. But there are plenty of other interesting things, so I'm biased as many others. Okay, there was today a question just recently from someone asking, they were having a problem that they seem to be moving soft and external links around frequently. And the question was, well, how can, and so just as a reminder, a soft link is basically a link whose destination is specified as an HDF path name, as a /something/something, or even without a leading slash. But since it's a soft or symbolic link, as we call it, there's no requirement that this HDF5 path name can be actually resolved. It can be resolved to an object, a group, a data set, or committed data type. And likewise, for an external link, the distinction is only that there is still, it's a pair of think of it as a file name and then an HDF path name. And so an external link, the referent of, if there is then one, of an external link can be in another HDF5 file. Now, as I said, since dangling, like dangling URLs, dangling soft and external links are perfectly permissible, the HDF5 library will not prevent you from creating such a symbolic link. Any kind of verification or validation, whether that can be resolved, is not a requirement for creating one of these links. And so then the question is either when you move it, or how do you potentially detect broken soft or external links? And unfortunately, there is not a perfect match for this task. The first thing that often comes to mind, because it sounds a little bit like it, is this function called H5L exists, and I linked the reference manual entry here. But as the name also suggests, that function really just checks only for if, as we know, a group is a collection of links and link names have to be unique in that given group, and all that H5L exists really tests is whether a link of a given name is present in this group. Think of it like in Python speak, for example. Let's say you have a dictionary and you want to check if a certain key is present among the keys in this dictionary, or if you have a set, whether a given object is present in that set. That's what H5L exists does. And again, if the link whose existence, let's say, you could ascertain this way, that would be no guarantee for that link could actually, let's say it's a symbolic link, a soft link, or an external link. That H5L exists. If that link exists under that name, H5L exists will return true, that link is there, but you cannot draw conclusions in any way about whether that link actually resolves to another HDF5 object. So H5L exists is not going to do the trick. However, there is another function called H5O exists by name, and that you can provide a handle, a location ID, as we call it, of HIDT, which can be a file, a group, a data set, an attribute, and whatnot, and a path name. And then this function will indeed test whether the provided path name with respect to that given handle can be resolved to an object. I say it's not a perfect match because let's say you have, for example, an external link. You would have to, so you could use this function with a soft link as is, and there wouldn't be any problem there. However, with an external link, since potentially the, let's call it the file component with respect to which that path name specification is to be applied, you would first have to obtain a handle to that to an object in that external file before you could call this function H5O exists by name, because that first argument, that location ID, in this case probably should be the file ID, a file handle. And so in order to call this function again, you have to first obtain a handle to that file, which is of course part one of this test. Is if you sort of are unable to call H5F open on the file name portion, so to speak, of this external link, well, that will tell you right there that you don't have to bother to resolve that path name because you can't get a hold of that file to begin with. So that's why I'm saying here it's not a perfect match, but assuming that you can deal with that case, then yeah, H5O exists by name is a help, if not a solution, to check if you are dealing with soft or external links that are broken. And of course, in the case of hard link, this is not possible because in the case of a hard link, the destination is specified as an, at the end of the day, address in the same HDF5 file or token, more generally speaking. And you cannot create hard links to non-existent objects. So hard links cannot be dangling under no circumstances. So there is no such thing as a broken hard link. Okay. Any questions so far?
No questions, Gerd.
Okay, thanks. Okay, next topic that came up was the native L-double story. And we talked about this already last time a little bit. And that thread got a lot of responses and contributions from Stephen Varga, who also provided some excellent examples. But and I think that definitely has helped to illustrate the problem that the fundamental problem with L-double as a C data type is really that if you're in a C program, you use L double, you are in a way making yourself dependent on the compiler and processor, because the compiler may interpret it one way, and then there may be hardware support in the processor for the compiler's understanding of that long double type, or not. There might be also software emulation somehow. And if you are doing that with respect to HDF5, where you really want to a degree, ensure the ability to unambiguously recover, interpret the data that are stored in this HDF5 file, that is a big problem. You are opening a can of worms there, because once that HDF5 file, depending on how you decided to store these L double values in the HDF5 file, a recipient of that file may or may not have access to the same compiler processor, to the same environment, and so forth. And that's where things start getting problematic. So fundamentally, and I think that is sort of the what the different contributors to this threat are saying is, you have basically two options if you want to save information like this in HDF5. The first thing, and that's my second bullet here, is sort of, just treat it. We recognize it's something very specific to maybe a compiler and processor, to a platform, let's call it that. And since anything that can be represented as bytes, as uninterpreted bytes in this case, in HDF5, we have something called an opaque data type. So let's say you want to set 16 bytes aside for storing values of this L double type, then the only thing you should ensure is that in addition to preserving the bytes, which again are architecture specific, you're basically taking the bytes from memory and you're putting them sort of verbatim, one-to-one, into the HDF5 file, and the HDF5 library will just take them from you, put them in the file, not change them in any shape or form. So that's good. But then the burden on you as the creator of that kind of HDF5 file is that you also decorate that opaque data type, and the opaque data types have the so-called tag for one, where you could provide some metadata about the compiler, the platform, the circumstances, and whatnot. But that you're getting on a slippery slope there, because there are many different conventions how you might do that. Another approach might be, rather than using the tag or just using the tag for shorthand, it's really just an ASCII string at that. You could create a committed data type. So you could create that opaque data type object, so to speak, and link it into the file hierarchy. And then it is an HDF5 object. And you could decorate it with attributes, for example. And then you could use the attributes to, if you don't want sort of a weird ASCII string with all kinds of conventions baked in, you could have, for example, attributes on that opaque data type, where you say something about the number of bits in the mantissa, how many bits you are spending on a bias that you have in the floating point representation, and so forth. But again, it's in a way arbitrary still, because you are making up a convention for that. The alternative, the second approach, and in a way a little safer, would be to say, not only can you create these user-defined types, such as compounds and array types and whatnot, or these derived data types, as we also call them, you can also create more specialized versions of these, call them atomic or elementary types, such as floating point data types. So there is a well-defined model for how to create a user-defined floating point type, where you have to specify the position of the sign, the number of bits in the mantissa, the number of bits in the exponent, the bias, and then certain normalization primitives. But that in and of itself is not sufficient. That will just unambiguously put certain metadata into this data type object that you would have to, in a way, reinvent if you went down the opaque data type route. But then, in addition to that, to, in a way, establish a conversion path, you would have to provide functions that could convert, for example, a floating point number in this sort of non-standard, let's call it that, representation, let's say, to a double precision floating point number. Or if, again, you have a compiler or a platform that has other floating point types, then you could write conversion functions that convert this sort of HDF floating point type into that platform-specific compiler type. But that function, you have to write that. We call this a so-called soft conversion function. You would have to write that because that function would also have to deal with overflow and underflow handling, how infinity, positive and negative infinity is represented, and so forth. So that way, it's a little safer because, again, there are certain standard metadata that comes with it, and the sort of the data conversion pipeline is also, like the filter pipeline, relatively well understood and so forth. But it's still, it is still not very convenient, and it can't be in a way, because the moment you are dependent on compiler / platform specific things, you are in a tight spot, and you are in a way surrounded by all kinds of dangers that you may or may not be aware of. Okay, so I'm going to leave it at that, but this is a can of worms. Then there is this ongoing thread where the user describes sort of read errors. He provides that stack trace and so forth, where it looks like, yeah, at the end of the day, the library he's calling, I believe, H5O get info or something like that. So he or she is trying to retrieve information about an HDF5 object, and the error stack goes all the way down to the read, the POSIX read, or the emulation of it in Windows, and that's where it fails. And the user said that errors are random, on the same file. Sometimes they occur on the file, sometimes they don't. Sometimes they occur on, they typically occur on different objects, more likely with larger files. So right now we don't really have a coherent picture. Apparently, yeah, the user said that it's Windows software only in this case, so we don't have a comparison with Mac or Linux or something like that. And we are trying to sort of get a sample, although that may not help us very much, because it appears that on the same file, it sometimes succeeds, sometimes fails. So I don't think that the file is corrupted somehow. It must be something else. But anyway, we will get a sample. But in the meantime, what I suggested to him is, well, at least for the smaller files, I believe the user said that it's between 1 and 10 gigabytes or something like that, which in today's money is not really very large. But you could try to use the core VFD, where you effectively load the file into memory, and then all I/O operations, so to speak, except for the loading of the byte sequence, the blobs from the file system. Okay, if that fails, then there is a problem. But then once that file image is loaded into memory, there is no disk access and so forth. And so I would expect that to work just fine, and those errors to kind of disappear. Not that that tells us anything new, but it's just a good confirmation of that, yeah, the file structure is sane, and there isn't something going on with sort of a weird type of corruption error. But yeah, to be continued, it's hard to say at this point. I'm going to pause here and just ask, are there any questions up to this point?
So far, so good.
Okay, great. So then there was another interesting thread, and I haven't gotten a chance to reply yet. But Stephen actually did a great reply. There was a user asking about reading and writing multiple files using multiple threads in C++, and that's great. And the user actually, I congratulate him or her, they did their homework. They discovered that, yes, you can build the HDF5 library with thread safety enabled, and that just makes it safe to use with multi-threaded applications. However, that means in particular that multiple threads can open HDF5 files independently. But I think the user pointed that out correctly, his or her impression was correctly that the limitation remains that already for the open call, because there are multiple threads, they are in the same address space, so they are sharing the same address space, they are sharing the same instance of the HDF5 library in this case. And since only at least the way the current implementation stands, only one thread at a given point in time can be executing code in the HDF5 library. For example, if we just talk about opening or creating HDF5 files, calling H5F open or H5F create, not all of them can happen truly simultaneously. Even if you have 64 or 96 cores and you want to create 32 files, these 32 calls to H5F open to different files or to the same file, or H5F create calls, they cannot possibly be in the library simultaneously, because there is a mutex, a global lock, that basically, if you are the thread that is able to grab it, to acquire it, then you are the one that's executing library code, and everybody else is sort of kept out of the library. And only once you sort of relinquish that lock, another thread can sort of jump in and start executing their thing. So what are the options? Does that mean that's the end of the story? No. There are things that you can do. Number one, and I think Stephen provided a very nice example, and there are also good reasons why you would do that under certain circumstances, you can have multiple threads in a way queuing IO requests, and then have a single thread that basically takes the next IO request out of that queue. So a single thread servicing these IO requests. That's one strategy that would amount to, in a way, serialization, you could say. And that might be effective because there is certainly overhead, and your IO subsystem may or may not be capable of sort of really sustaining multiple threads doing IO at the same time. So that's definitely one scenario. Another scenario, and I would call that the advanced mode, is you can, if you carefully plan, and I'm talking about reads and writes here. So if you're only interested in reads, things are a little simpler, or if you're interested only in writes, things are also a little simpler. But let's assume we have both at the same time. What you can do is, as long as you carefully plan how and when data sets, for example, get allocated and groups get created and attributes get created and written and so forth, as long as you can tightly control that, and then be sure that when you want to start reading from a data set or writing to a data set, that the underlying file space has been allocated and so forth. What you can do is basically separate these call them bookkeeping tasks or allocation tasks and so forth, from the actual reading and writing tasks, which you can perform concurrently outside of the library. And again, this is a little more advanced because in doing so, you will have to use some of the introspection functions of the library, where you, for example, depending on whether your layout is contiguous or chunked or compact, you would have to obtain certain file level metadata, for example, about, well, for a contiguous data set, for example, where does the payload, where is that contiguous space in the file eventually, at which offset does it begin? What is the size, the element type of an individual element, and so forth? And there are functions to discover that. And then if you have that, you can just go off and use standard p-reads or p-writes if you're using p-threads. And that's all good. And likewise, for chunked data sets, you can discover for a given chunk data set, for example, where the chunks are located. And then you can do the same thing, use p-reads and p-writes and so forth. So there is, in a way, a serial portion where there is some coordination required that may have to do with allocation and discovering that metadata. But once you have that, you can just go off in regular p-threads, for example, or whatever the platform threads you use, and then use that information to access the file concurrently, unlimited. The HDF5 library at this point is out of the picture, and you can do whatever you like. It's advanced, and you have to know what you are doing, but it's certainly possible, and people have done it. And yeah, it just requires a little bit of preparation. Okay.
Can I have a question here?
Sure. Mm-hmm.
Hey, Gerd. So you mentioned that people have done this one because it sounds like a complicated solution as opposed to, say, having a queue, which can be a very simple solution. So we picking up a complex developer time here, but for what benefit? Like, is there a way to compare?
Yeah, I think maybe, for example, it probably depends on the use case. For example, let's say you want to copy data from one HDF5 data set to another HDF5 data set. I think if you use this queue where you basically, and let's assume that this copying of data between data sets or between files happens incrementally, where you don't copy the entire data set in one shot, but you have sort of a window size, let's say, where you say, I'm always reading 1 megabyte for argument's sake from the source data set, and then after that, I'm writing that 1 megabyte to the destination data set. In the case of the queue, yes, of course, you can enqueue these requests in the right order, and that will be perfectly fine, and it will work. However, I think what you cannot do in this approach is to, for example, overlap, let's say, the writing of the previous buffer with the reading of the next buffer or something like that, or have multiple sort of slots where you can service multiple reading requests and multiple writing requests at the same time if you want to do some kind of double buffering or something like that. So it depends on the use case. I think there are many use cases where the queuing model is perfectly adequate, and you will get good performance, no question about it. But then there might be use cases where you are maybe leaving performance on the table, assuming again that your I/O subsystem is really capable of servicing these different outstanding or ongoing operations, and it depends.
Not just the reason, because say option A, that's not a lock-free queue. I provided a locked queue. There is a lock-free version of the same idea.
Okay.
Yeah, so there are queues. They are used in computer science, very regular. So this was a lock queue with locks. There is a lock-free implementation of the same idea. Okay, so that we can measure the performance is provided. But I am wondering if the alternative can be done. Or is it like it is possible, but it's really expensive to do? In terms of like the developer's time, because
for sure, I think it is. I mean, debugging it, because it's probably even an experienced developer may not get it quite right in the first round.
That's what I'm thinking, because it looks like, say, the reason I'm asking, because I looked at to implement the entire HDF in C++ in templates, alternative what you just described. So more or less, I am somewhat familiar like the complexity of it. Third version, using say queues with locks or lock-free queue. Lock-free is a little bit more complicated, so that's why I didn't provide one. But the lock version performs reasonably well. It can be measured. So I think primarily, if someone is like off the bat looking for a solution where you want to implement a server that does the IO service, and then you have the external threads that does some sort of a workload, then it's a reasonable solution.
Yeah. Okay. I'm afraid we are out of time. We will never get to this picture, and I actually created a new picture, so maybe there will be another picture next week. The only thing I wanted to mention, in case for those of you who were interested in this ongoing discussion, remember we talked about this maybe 2 clinics ago. Lucas was proposing extending the virtual file driver interface to allocate device-specific buffers for FPGAs or GPUs and so forth, and handle that at the VFD level rather than polluting your code with lots of conditional compilation and so forth. And he created a pull request, and for now he's reworking it because it drew some interesting comments from HDF developers. But so if you want to follow up on that, I linked it here, because it's also interesting to see that, it's we welcome contributions, external contributions, but then sometimes in the discussion of the pull request, there are certain things that either we didn't make clear in the documentation, and that happens very often, or there are just sort of certain fine details that the external contributor may or may not have been aware of. But it's certainly it's very interesting to follow, and the technical arguments, the concerns and whatnot. So if you are interested in that, please take a look at that. And then so next week we'll come back, and then we will have, of course, John's presentation on April 1st. So we'll probably get to this before that discussion, if we get to it next week. But then I think that will be a great warm-up exercise to then follow John's presentation. Thanks for coming, and great discussion. Thank you, and I'll see you next week.
Thanks, Gerd.
Thank you very much.
Thank you.
Bye.